Okay, so today we are going to talk about something that honestly affects all of us, even if we don't realize it. We are talking about generative AI. We all know tools like ChatGPT or image generators or AI writing assistant. The thing many of us use for assignments, coding helps, or some days even for creating writing. Now, let me ask you something. Have you ever asked AI a question, gotten a very confident answer, and just trusted it, right? So most of us do. But the question is, do we actually know why it gave that particular answer? Probably not. And that is actually what this research paper is about. It introduces concept like explainable generative AI or GenXAI. Basically, it asks how can we make generative AI systems explain themselves, right? So we don't just trust them blind. So today I'm going to walk you through that in simple terms. So to understand this paper, we should understand traditional AI and shifting AI paradigm. Mostly AI systems were predictive. We give input or map input and get output label. For example, email, if an email is spam or not, we give image of, for example, a cat, and you know which object's image is in this identified. So Gen AI, however, produces entirely a new content. LLM generate text word by word, or diffusion model generate images step by step. So we can say that we all know traditional AI systems, right? Simple input, simple output. But generative AI systems is different. So instead of predicting label, it creates something new. For example, we give a prompt like write a paragraph, or let's say on climate change, and it writes a full paragraph. So it's kind of like autocomplete, but extremely advanced. Now that sounds amazing, but it is actually complicated because if something goes wrong, so how do we know, where it went wrong? Now let's talk about explainable AI. So explainable AI is basically about helping human understand how an AI systems made a decision. For example, medical AI system says a patient has a cancer. Probably doctor would ask why, right? Like what were the factors that were affecting that particular patient's health? That explanation built trust, right? So traditional explainable AI techniques were designed for systems like that classification models. But here the problem is generative AI does not give one small answer. It gives, long paragraphs, high resolution images, or traditional explainable AI tools are not enough. So let's talk about why this even matters. Now, firstly, the issue is hallucination. Generative AI sometimes produces information that sounds correct, but it is actually wrong. It might invent references, it can even create fake statistics. It might confidently describe something that is wrong, or even it might does not exist. Now, imagine this happening in healthcare system or in legal advice. That's obviously dangerous, right? So we need explainable systems that help us verify that answer. Now the second is biasness. As these models are, trained on a large amount of a huge amount of data, and if there is biasness in the data, so model can learn biasness. So we cannot trace where certain behavior come from. Now, the third is trust. Let's be honest, if something feels black box, it makes us uncomfortable, right? So, explainability increases transparency that ultimately will increase the trust. Now, here is where things get interesting. Explaining generative AI is much harder than explaining traditional AI. Now the question is why? So the first thing is complexity. If a model says, for example, if the email is spam, that is one decision. But if, for example, a chat GPT writes 500 words, that is hundreds of small decisions. And on the basis of these 500 words, we're generating. So each word is chosen based on the probabilities. Every word depends on the previous word. So technically, to fully explain a paragraph, why would you need to explain every single word choice? That is complicated, right? Now the second is training step. Modern generative AI systems are trained on pre-trained massive data sets that fine-tuned, then it is aligned with using, human feedbacks, and then, filter for safety. So when model gives answer, which stage is affected, or what are the factors that are affecting it? So it's not that simple. Next, third would be many models are black box. We don't know what data that were trained on. So simply explainability becomes harder. So because all of these challenges, the authors introduces a new concept, explainable generative AI. It's a framework and the idea is very logical. Instead of trying to explain, everything after the model generates it, we should design the system to be explainable from beginning. So, generative explainable AI system should follow the steps like it should generate the content, then explain why it generates it. It allows the user to ask follow-up questions, then verify the correctness, and the last, protect the privacy as well. So it's all about building, transparency into systems foundation. So the paper also organizes that explanation methods into categories. The first one is internal explanation, like look inside the model, like attention pattern. The second thing is data-based explanation. These try to identify which training example influence the output. And the third would be, prompt-based explanation, like why did you say that, and it explain reasons in, human language. So the fourth one can be post hoc explanation. These use external tools to analyze the output after, it is generated. But also we can explain scope of the example, scope of the explanation. For example, explain whole answer, or if we want to explain one paragraph, like this. So here it is the important question, that is, what makes explanation good? So people listed some qualities. First, it should be verifiable, like can we check if explanation is correct? Second, traceable, like can we trace where the information come from? Third, personalized, difference over many explanation. A researcher may need, for example, personalization could be adapted to based on the user expertise. For example, different user may need different explanation. A researcher may need technical detail, but naive user may need a simple explanation. So the fourth one would be security. We know explanation should not reveal the private training data. And the fifth one would be efficient, like generative explanation should not require too much computation. So here is something interesting. How do we even measure if explanation is good? It's not like something accuracy. We have to ask, how do we understand it? Does it increase trust? Or so it's still an open research area. So the current problems that are defined in this paper is no standardized benchmarks. There are difficulties to measure explanation quality. Does the user understand that specific explanation, or trust? Does that explanation is building the trust, or human-centered evaluation that is also required. So to wrap up this, if AI is going to shape our future, it must be understandable. We are entering a world where AI can speak, write, design, and reason faster than humans. So, but just something sounds intelligent does not mean we understand it. And if we do not understand it, should we, blindly trust it? So generative explainable AI reminds us that power must come with transparency. If generative AI is going to guide decisions in real life, real patients, real laws, and real education, then obviously it must be accountable. Because of the future of AI, should not be black box. It must be transparent, or it should be glass box. Powerful, but it should be visible. So it's like something. If AI is shaping our future, it should be understandable, it should be explainable, it should be human understandable. That should not only a black box model. So it was a very simple kind of explanation. To wrap this up, uh, we basically discussed that explanation matters. In traditional AI systems, it was easy to explain something. We have, if you know a simple machine learning pattern, we have some problem. We have a single solution for this. For example, if we give an image, or if we say if an email is a spam or not, it just simply gives the output, like for example if image is spam or not. So just a single output. But if we are talking about generative AI that is producing a high resolution image or a paragraph or something, a PDF, something like that, so it's very difficult to understand why it is producing that particular text or that particular information. And each word, we know, the generative AI works based on the probabilities. Each word is chosen based on some probabilities. Every word is dependent on the previous word. So it is very important to know what are the factors that are affecting the generative AI, or that are causing that particular solution of generative AI. uh, so explanation is very important, especially in the cases where explanation matters. As I talk about, if healthcare system, if AI is being used in healthcare system, so obviously, if a system says a patient has that particular disease, so definitely use a doctor will ask what are the factors, what are the things that are affecting that particular patient's health. And obviously, we would definitely not want that the system lags, or system answers incorrect. So trust is important. Trust is transparency is important, and also building, protection of the privacy of data. So it's about transparency into the system's foundation. And the solution that is being given in the paper is uh, developing a system that is built based on the transparency into the system's foundation. And it should work like that. For example, a tree, it should respond, then it should be fine-tuned, then aligned with a user feedback. For example, if AI is giving the particular answer correctly or not, then filter for the safety and security. So it is like that. I hope this is understandable to you. To wrap this again, AI shaping our future, so it must be transparent. It must be understandable. It should not be black box. It should be a glass box. It If something is intelligent, so it doesn't mean we understand it. If we do not understand it, then we cannot trust the things blindly. So generative XAI remind us that power is comes with, for example, transparency. It comes with trust, and it is going to guide the decisions in real life. So it must be accountable. So I hope this is clear to you all. So if you have any question, you can ask. I'm open to questions. Okay, did you experiment further on this topic particularly as well? Basically, I have not practically performed it, but the idea is generative AI is one of the most powerful technologies of our time. But without power without explanation is uncertainty, and obviously uncertainty create risk. Risk obviously reduces the trust. So without trust, even the most advanced technology cannot be succeeded. And generative AI is not about slowing down the innovation. It's about making innovation responsible, because in the end AI should not just be intelligent, it should be understandable, and that's the foundation of a trustworthy future. So the idea basically is the field is growing, and we can say we have to ask the explanation if how do we even measure if an explanation is good. For example, if a system is generating an explanation of a generative AI systems, so it's not like measuring accuracy. We have to ask, do user understand it? Does it help detect errors, or is it helpful in decision making? So there is no currently no universal benchmark for this, and this is still an open research area. So let's conclude this. Generative AI is no longer, I think, a future concept. It is already shaping healthcare, education, or law, or even businesses, and even the way we think and write. But intelligence, again, without transparency is risk. And if we continue building systems that generate powerful outputs without, understanding the reasoning, uh, or we are building tools we cannot fully control. So generative explainable AI is not just a technical improvement, it's a necessary evolution. Because in the end, the goal of AI is not just to generate answer. It is to generate answers that we can trust, we can verify, and we can responsibly use. So that responsibility starts with explainability. So thank you for your time, and hopefully it is an interactive session for you. If you wanna connect with me, I can share my again screen with you. So if you wanna connect with me, that's you can connect me on LinkedIn. That's my LinkedIn link available here. Hopefully that session is interactive and knowledgeable for you. Thank you. Okay, I have one question as well regarding business and black box. How do you suppose it could be implemented in enterprise industries where trusting tech is risky due to confidential data? Obviously, the proposed solution also provides a point where I have also given you something. For example, let me share my slide again with you. Okay. Mm. So this is where I have talked about security and privacy. Avoid leaking sensitive data. So the system that the proposed solution that is generating, so it must be secure. It must secure and provide privacy. So obviously we have some sensitive information, and we should trained our model in a way that it is generating content, it is also securing the information that is being used during the training. So it is how it works. Like we are when we are generating a system, for example, generative explainable AI, we should train a model in a way that it should avoid leaking, sensitive information. We are protecting that. So it should not, reveal the information during explanation as well. Okay, thank you. So again, it was all about a generative explainable AI. And thank you for your time. And hopefully, this is an interactive session for you all. Thank you.